Hi students, welcome to Jayadev Academy. My name is Kranti Kumar. I am physics faculty here. So now we are discussing a physics subject. See, in the previous class, I discussed about how to write a two-dimensional vector and three-dimensional vector. Okay. So now what is our task? So I am giving how to write. Okay. So our task is writing physical quantity vectors so writing physical quantity vectors. So we already know what is vector, right? We already know. So what is the vector? What is vector? So vector is both magnitude and direction, right? See, what are those examples? Physical quantities. Position. Okay. Displacement is also vector. Yes. Velocity also vector. Yes. Acceleration also vector. Yes. Force is also vector. Yes. Electric field also vector. Electric field also and vector. So now we are going to write 2-dimension and 3-dimension of all these vectors. So why? Because what is our topic? Motion in a plane. This is our main topic. So in that main topic, before I am going to explain the concepts of the motion in a plane, what motion in a plane? In the motion in a plane topic, we have to learn Newtonian equations, that is the kinematic equations, you know already, that V is equals to U plus AT, V square is equals to U square minus 2AS, right? Some equations like that. So those equations we have to write in 2-dimension and 3-dimension. That is the motion in a plane. We already learned some kinematic equations in a motion in a straight line. Okay, so those equations we have to write in 2-dimensional. For that, we have to learn how to write a position, a vector. Be careful. Position is a vector. You have to write this position vector. See, represented with R cap. Okay, this is R. I am writing, okay, don't neglect it like this. Should I write like that? Should I write like that? Okay, please, okay, this is R, this is R vector. Displacement vector is nothing but delta R vector. This is R vector. Displacement is nothing but delta R vector. Velocity is nothing but V vector. And acceleration is represented with A vector. And we are not discussing the force vector and the electric vector in this topic. Actually, we can write. If you know this, we can write. See, be careful. While I am writing R, V, different. I will write R like this. I will write V like this. Don't think, sir, you are writing V and R. No. Please be careful, okay? Please be careful. So these vectors, position vector is represented with R vector, displacement vector is represented with a delta R vector, velocity is V vector and A vector. I am writing these vectors in 2-dimension. Let's take writing a vector in 2-dimension. Write a vector in 2-dimension. 2-dimension. So I am writing. Now I am discussing about a 2-dimension vector. So I am taking position vector. Okay, I am writing position vector, that is represented with the R cap. Sir, what is position vector? A position vector is nothing but a point. I stand here. This is my position. I wanted to tell my position in the vector form. That's it. Sir, position means like it's like an arrow mark. No. An arrow mark is representation of the vector. That's it. Arrow mark is not a position. Arrow mark is representing a vector. That's it. See, take xy plane. So we are writing in 2 dimension, right? 2 dimension is nothing but xy, right? So take xy plane. This is the x. So this is the y. So somewhere this is the point P. Okay, this is point P. I wanted to represent this point in 2 dimension vector. What I have to do? Actually, this is the point where it is located on xy plane. I am representing this point with a vector. Okay, don't confuse with the position and vector. This is the representation of the position. I represent this position with the arrow mark. Okay, so see, this is the position. I am representing this position in vector form like this. So then I call that point like this. Then I call this is a vector, position vector. Actual position vector is this. A point is located somewhere. That is the position. This is the position of the point. But I am representing this point in the form of vector like this. So that point is like change its physical appearance like arrow mark. Okay, you think, sir, this whole thing is position? No, position is only one point, but I represent this position like this. Okay, see, this is the position vector and this is the some r. We already know if the vector is in xy plane, so xy plane we can write this is as you can write it has x I cap, right, and y j cap. Then okay, it's completed. See, right, write the position vector. I'm writing the position vector, position, that is r cap. I'm writing in xi plus yj. So this is the position vector. This is the position vector. Okay, hope you understand, right? So don't neglect it, please remember this. If anyone asks, so what is the position vector? Write immediately position vector is x component. If anyone asks what is the position vector, right? Position vector is like x component I cap plus y component j cap. This is the position vector. Okay, please remember it. Next, we will discuss writing about the displacement. Okay. Okay, next come displacement. First, what is displacement actually? See, second, displacement. Nothing but delta r vector. Okay, just see. This is the 2 dimension, right? So what will happen if I wanted to write this position vector in 3 dimension? X, y, z. How I can write? You can write xi cap, right? Yj cap and z k cap and z k cap. See, this is the representation of the position vector like this. Okay. Next, this is the 3 dimension. This is 2D. Yes, this is. I no need to write, right? You already know, because here we got a 3 components and here we got 2 components. Right. Next, displacement vector. So what is actual displacement vector? See, we already learned in our 10th class and also in the motion in a straight line. I will explain the simple one. Displacement is nothing but, this is the point 1, x1, y1. This is point 2, x2 and y2. See here actually. So these are the 2 points. What is the these are the 2 points? Actually I started here. This is my first point. And I move like this. I end here. This is my second point. Okay. I located my first point as x1, y1 and on second 2-dimensional plane. And I located my final point as x2, y2. If I wanted to find the distance between these 2 points, that is called displacement. Okay, so the distance between these 2 points. So what is displacement? Displacement is nothing but the distance between 2 points. So what is the distance between 2 points? See here, this is a position, right? This is one position and this is another position. This is the position 1 and this is the position 2. I can say it like that. The distance between the 2 positions also called displacement. We already know position vector. Position vector r is equals to xi cap, y cap, yj cap, right, in 2 dimensions. Similarly, we have to take the distance between these 2 points. See, x2 minus x1, if I wanted to take a distance, I can take x2 minus x1 is 1 point and y2 minus 1 is 1 point. So this is my 2 points of distance between these things. Let's see, take another example. So this is my location and my location is at position 4 and this is at position 8. So what is this value? 8 minus 4 is equals to 4. So this distance is 4. This is displacement. Hope you understand, right? So let's write in displacement. So now I am taking a graphical representation. So I already said the graphical representation is only for understanding purpose. This is x, this is y. So I am taking these 2 points. Similarly, I am taking a point 1 here and take a point 2 here. So right, actually this is the position 1, right? This is the position 1. I can call it a position 1, and this is I am writing r1, and so this is the position 2, and I can write it as a r2. So what I need distance between these 2 points, that is like this. Like this. I need distance between these 2 points, that is nothing but 2 minus something. Okay? So that is nothing but this is R2, so that this is R1. This is the displacement vector. Okay? Hope you understand. Now come to the definition, come to the formula, analytical method. Come to the analytical method. Okay? Come to the analytical method. How to write that analytical method? Take displacement. What is the displacement? Displacement is nothing but R2 vector minus R1 vector. Right? See this one. R2 vector minus R vector. I took the 2 positions. I already know this position can represent with the vector r cap. R vector is another form of showing position, r vector, right? So this is r vector and this is another r vector, and the displacement, the distance between these 2 points is given by displacement. So that is r2 minus r1. Hope you understand. Right? What is r2? I can write r2 like this. x2 y cap plus y2 j cap, right? Minus like this, right? So if I take this point is this point as x1 y1, if I take this point as x1 y1 and this point is x2 y2. This is a representation of the point. You can learn in geometrical representation in mathematics. Okay? x2 y1. I am representing the r2 r1. I represent r1. Okay. Just before I am going to explain this, I will explain. See, r1 can written as r1 I can written as x1 y1 cap, right? x1 I cap plus y1 j cap, and also r2. This is r2, and r2 I can written as x2 I cap plus y2 j cap. See here, right? So why? Nothing about. See here how I explain. So this is the xy, right? So this is xy, and this is xy, and this is associated with the x and y. So that's why I write r vector is x cap y cap. Similarly, here I also took x1 1 I cap plus y1 I j cap, x2 I cap plus y2 j cap. Let's take displacement of this. So see, displacement formula is this one, that is r1 vector. Write this one. So what is the r2? This r2 I cap plus y2 j cap minus x1 I cap plus y1 j cap. So we have to bring all x terms together, so, x components, that is x2 minus x1 I cap and plus y2 minus y1 j cap, right? See now, this is r2 minus r1, r2 minus r1. This is the two-dimensional vector representation of the displacement. Okay, two-dimensional representation of the displacement. Now we have to write simplification form, like in the previous class. If you observe, if you remember it, we write a plus b, right? A plus b as ax plus bx I cap plus ay plus by j cap, right? So then I write this one as r vector and rx I cap plus ry j cap. This is the simplification of given vector. Similarly, we have to write this is as in the simplification form. So r2 minus r1 can written in the form of, this is a minus. If this is the plus, I can write r vector. If this is the plus, I can write r vector. That is okay. But this is not plus, right? This is not a plus. This is a minus. So how I can represent minus? I can represent minus with delta. With delta. Delta r cap. Okay? Hope you understand. So this is the delta r cap. Then what did happen? This is delta x I cap and plus delta y j cap. Don't confuse with the simplification of form and original form. If you see any question like this, immediately you have to imagine, okay, delta x is nothing but x2 minus x1. Delta y is nothing but y2 minus y1. Like that. See, I can write here, delta r is nothing but r2 minus r1. So these are vectors. So this is the displacement vector, and delta x I can written as x2 minus x1, and delta y I written as y2 minus y1. So this is the representation of the displacement in two-dimensional vector. Sir, what if they give three dimension? See, three dimension is nothing, na? So see, if they give the three dimension, so delta r vector is in x, y, z. We can write is like a delta x I cap, delta y j cap plus delta z k cap. Okay, delta is nothing but x2 minus x1 I cap plus y is nothing but y2 minus y1 j cap plus z is nothing but z2 minus z1 k cap. So this is the representation of the 3-dimension vector. Okay, see, if you know how to express a vector in 2 dimension, then nothing to worry, just you add extra z, that is. So that's then you will get the value. Okay, we complete here. Now we move to representation of the displacement. Okay, just we completed vector and we completed position and displacement. So now we move to represent a velocity. Okay, velocity. Okay, let's there is a 15 minutes of time there, right? Okay, velocity. Take a velocity. Third one, velocity. Representation of velocity in 2 dimension. Okay, I already know, I already explained, everything is in 2 dimension only, we are explaining. So what is actual definition of velocity? See, velocity is nothing but displacement by time, right? By time. So what is displacement? What we find displacement? Displacement is nothing but delta r, right? And time is also I am taking as a delta t. See, what is delta r? What is delta r? Delta x I cap plus delta y j cap. Take it. Delta x I cap plus delta y j cap divided by delta t. I am writing this one like this: delta x by delta t I cap plus delta y by delta t j cap. So what is delta x by delta t? Is nothing but Vx, this is x I cap, Vy j cap. See, this is the vector representation in 2D. This is a vector representation. Sir, okay, you explained. So at the same time, I am explaining acceleration also. I am explaining acceleration. That is a vector. See, what is actually here? See, what is the meaning of acceleration? What is the definition? Acceleration is velocity divided by time, right? So what is velocity here? See, this is the velocity, right? This is the velocity, right? Velocity and time. This is the time. Okay. Now I am writing velocity like this. Okay. And this is the time. Okay. Sorry. Velocity by time. So change in velocity by time. I can write velocity. So like this. So how I can write this delta v vector? So we can write a delta v vector. See, this is a vector. What if a delta v? So this is delta vx I cap plus delta vy j cap. Right? Similarly, here I am taking the same thing. So delta v, that implies delta v I can represent as delta vx I cap plus delta vy j cap divided by delta t. Hope you understand, right? See, delta Vx divided by delta T I cap plus delta Vy divided by delta T j cap. So finally what I get, so this is, I can take it as a acceleration Ax I cap plus Ay j cap. This is vector acceleration in 2 dimension. Okay, hope you understand. So this is the vector in 2 dimension. So this is the velocity vector in 2 dimension. This is the velocity, this is the acceleration vector in 2 dimension. So what if they ask 3 dimension? See here, 3 dimension is very easy, man. So if they ask 3 dimension, we have to write x component, y component plus z component. That's it. If they ask acceleration is also in 3 dimension, x, y, z, you have to write ax component, I cap, ay j cap plus az k cap. This is a 3 dimension vector of representation of the velocity. This is a 3 dimension representation of the acceleration of vector. Let's come to the discussion about the instantaneous velocity. So here I am explaining the same thing. Instantaneous velocity. What is instantaneous velocity? You already learned here, you already learned in the previous classes. Instantaneous velocity is nothing but velocity at particular time. Okay, so that's how we can get it. See, instantaneous velocity definition is this one. So this is the instantaneous velocity. Limit delta tends to 0 and delta r divided by delta t. This is the instantaneous velocity definition. So what is delta r vector? We already know delta r vector I can written as delta x I cap delta x I cap plus delta y j cap divided by delta t. That implies limit of delta t tends to 0. So delta x by delta t I cap plus delta x by delta t j cap. So I am taking limit over to these 2 components, and limit delta t tends to 0, delta x by delta t I cap plus, and limit, I'm taking this, I already told I'm limiting this over these two components. So delta t tends to 0, and that is, this is y, right? Sorry, this is the y. So this is delta y divided by delta t, this is a j cap. See here, finally what we get is, if the limit is operating on the delta, so it will transform to dx by dt I cap plus, so dy by dt j cap. So this is the instantaneous of velocity definition in 2-dimension plane. Sir, okay, what about the acceleration? See, I no need to explain acceleration. Acceleration is the similarly, find instantaneous acceleration by yourself. Okay, find instantaneous acceleration by yourself only. I am not giving, you have to try it and you have to send it to the Jayadev Academy app. instantaneous acceleration. See, what is instantaneous acceleration? We have to take instantaneous acceleration like this only, acceleration and limit. So time tends to 0, limit time tends to 0, and delta v velocity divided by delta t. So should I explain? No, I no need to explain. The same thing. You have to take limit delta t tends to 0. Okay, what is delta v? So delta v is nothing but delta vx I cap plus delta vy j cap and divided by delta t. So then you will get the answer in terms of the dv by dt, that is the instantaneous of the acceleration, instantaneous of the acceleration vector. Okay, so hope you understand. So today we complete all the concepts which is related to vectors, and we've done how to solve all the questions and how to write the vectors in two-dimensional forms also, and also I explained the addition and subtraction of the two and three-dimensional vectors, and also explain how to express a position, displacement, velocity, acceleration vectors in 2 and 3 dimensions. So these all concepts are required for us. For what? To solve the problems, to find the kinematic equations in 2 dimensions, to write a projectile motion of the object in the air. We need all these requirements to move further. Okay, so hope you understand. So please read all the subjects, all the topics what I explained. Tomorrow we are going to explain the great example, that is the projectile motion. That is the this is very exciting to solve some equations from that concept. Okay, if you understand, if you wanted to understand those things, so please go through all the topics. Okay, once I request you, please don't forget, read, and it will remember forever. And we will discuss the two-dimensional motion, projectile motion, in our next class. Thank you very much, and we will meet in the next class.